Hello everyone, this is Mthobisi and welcome to our YouTube channel. Today we're going to be looking at grade 12 trigonometry, which I call trig value by letter, and that is when you're solving for trig ratios with an unknown variable without using a calculator. So I'll break it down in 4 key steps with the following example. So let's say that your example is if sine of 32 degrees is equals to a t, then express each of the following in terms of t. Now, let's say they give you A to be sine 212 degrees, B to be cos 58 degrees, and C to be cos 68 degrees, D to be cos 62 degrees, and then E sine 2 degrees, and then F to be sine 16 degrees. Now, the first thing that you may note from the question above is that you're given sine 32, which is just equal to a value of t, which is not a ratio, so you have to make t to be in a form of a ratio. Another thing that you must note is that 32 degrees is acute, and which means you need to draw a sketch. So a sketch must be drawn. And first things first, you look at SOHCAHTOA. Now, sine 32 degrees is equals to a positive value of t, but t can be written as positive t over 1, which means that this is my opposite over my hypotenuse. Now, whatever triangle I'm going to be drawing must be positive. First, I need to check. I have sine being positive here and here, but I have an acute angle only here, which is 32. And when it's 32, the opposite side is t, the hypotenuse is 1. Then we have an unknown side here, which is the adjacent. And how do we find an unknown side in a right angle triangle? We have to use Pythagoras first. Now, by using Pythagoras, it means we're going to have to say x squared plus y squared is equals to an r squared. Then we substitute, or we first single out x to be alone here, r squared minus y squared. Then, since we see that it's on the positive x-axis, we can simply say if we apply the square root, we're going to have a plus or a minus root of r squared minus y squared, but x will be equal to a positive root of r squared minus y squared, which is the same as square root of our r value is 1 squared minus t squared, and therefore this gives that x is equal to 1 minus t squared, and therefore this becomes 1 minus t squared. Once you've drawn the sketch and it has all the relevant sides, you need to ensure, according to rule number 1. Rule number 1 says, ensure that you have all angles in the right angled triangle. Now let's go back. We have 90, we have 32, then we must have an angle that completes the angles in a triangle, which is what? 180. So if we say 32 plus 90 plus 58, then we get 58 degrees. We get that complete 180 degrees. Now this brings us to our first one, which says sine of 212. Now 212 is not acute, so the first thing that you're going to do is to reduce by using what? 212 is found in this quadrant. That's the quadrant of 180 plus an angle. So we have to write sine of 180 plus 32 degrees. And I just write this. It's not necessarily equal to, but just to remind learners that this is the reduction I'm going to use. Now, at this reduction, sine is negative in this quadrant. So it's a negative sine of 32 degrees. Now, we're given sine 32, which is equal to t. So therefore, this means that this is minus t. Then we move forward to number B. Number B is a cos 58 degrees. Now, if you had not completed the angles in here, you wouldn't know 58. Now, this means that you'll have to tilt your wherever you've drawn, whether it's a paper or a book, make sure that you rotate or you rewrite this triangle. I think I have to do it. You rewrite this triangle such that 58 is on the adjacent side. You either tilt or you just rewrite the triangle, and then this will be your 38. And if 38 is here, this is your 90. And if 38 is there, this one is still 1. What was opposite to 38 is now adjacent to 58. I mean, it was to 32, not 38. 32 degrees is now adjacent. This means what's opposite to this one is what? 1 minus t squared. So this means that at cos 58, this is the adjacent of a hypotenuse. Now the adjacent side is t over 1, which is equal to a t. Whether you leave the answer in t over 1 or just at t. And also, the answer is also true. Why? Because this is also a cofunction. Cos of 58 is the same as sine of sine of 32, which is equals to a t according to cofunctions. So the answer is true. Now we go to C. Now C is cos of 64. Are we given anything about 64? No, we are not. But rule number 2 says we consider using double angles. Now for cos, we have 3 double angles. So the double angles will be a double of 32 degrees or a double of 58 degrees. Now, The double of 32 is 64. So 32 times 2 is just 64. So this means cos of 2 times 32 degrees will give us a double angle. So now it's advisable to use the double angle identity that includes sin 32. Well, sin of an angle, not sin 32 necessarily, but sin of an angle, because that one was given to us. We did not derive it. So it's wise to use that double angle. So we'll have to use 1 minus 2 sine squared of 32 degrees, which is basically, if we have to rewrite it properly, it's 1 minus 2 times sine 32 degrees squared. Sorry about that. And then this 1 minus 2 sine of t squared. So it's 1 minus 2 t squared. Okay, so it's preferred to use what you are given in the question. Then we move on to rule number 3. Now, rule number 3 says we need to draw two circles, circle A and circle B, or circle alpha and circle beta. What do we put in these circles? In circle A, we put our acute angles from the diagram. The first one would be 32 degrees. Second one would be 58 degrees. And then on this one, we put our three special angles. There is a video that we did on how to derive special angles. You can check it out. But in this one, you put 30, 45, and then 60. Now, so in here, you'd have to choose a pair that will make the angle that you're given. For example, in number D, this is cos of 62. There is no 62, you can't make a double angle of it, so you can't use rule number 2. But if you check here, how can I make 32 with adding or subtracting from one circle and the other? If I add 32 and 30, I get 62, which means I can now get that cos of 62 can be written as cos of 30 plus 32 degrees, which is a compound angle from cos of A plus B, which gives us cos A, cos B, minus sine A, sine B. Now, we can simplify our cos of 30 plus 32 as cos of 30 times cos of 32 degrees minus sin 30 times sin 32 degrees. Now, the cos of 30 is equal to, it's a special angle. So cos of 30 is equals to root of 3 over 2 multiplied by the cos of 32. You just go back to our diagram, we look at when that angle is 32, what is the adjacent? The adjacent is root of 1 minus t, t squared all over 1 So it's a root of 1 minus t squared all over 1. And that is being multiplied. Then minus sin 30 is just a half. Minus a half. Sin 32 was a t over 1. So this will become a what? This will become the square root of t multiplied by square root of 1 minus t squared all over 2 minus t over 2. You can leave the answer like this. And then for E, which is sine 2 degrees. Now sine 2 degrees, we can still apply rule number 3 because you can get sine 2 degrees by saying 60 minus 58 or 32 minus 30. So you can choose either one. So either choose 32 minus 30 or 60 degrees minus 58 degrees. Now, sine 32 degrees minus 30 is equal to, if we have to expand it, coming from sin A minus B, that becomes sin A cos B minus cos A sin B. Now, in terms of 32 and 30, this will be sine 32 degrees times cos 30 minus cos 32 degrees times sine 30. And this becomes a t over 1 multiplied by root of 3 over 2 minus root of 1 minus t squared all over 1 multiplied by 1 over 2. Then you can leave the answer like this or just simplify it to root of 3 over 2 t minus root of 1 minus t squared all over 2. Then the last one is number F, which says sine of 16. Now, here, rule number 1, 2, and 3 do not apply because we don't have 16 in the diagram. For rule number 1, we can say double or what to represent 16, and we can't use adding or subtracting to make 16 from the circle of A and the circle of B. So we have to apply what we call in rule number 4 half angles. Okay, how do we perform half angles? Let's say you have cos of 2a. Cos of 2a represented by 1 minus 2 sine squared a. Now you see that if we say a is equals to 16, then 2 times, or cos of 2 times the 16 gives us 32, which we know. So we can use cos of 32. So in here, we're going to say cos of 32 degrees is equals to 1 minus 2 times sin squared 16 degrees, because that is 2 times. Then now we solve for sine 16. We know cos 32 is the square root of 1 minus t squared, which is equals to 1 minus 2 sine 16 degrees squared. Then we take the 1 to the other side, or we take the 2. We take 2 sine 16 degrees all squared to the other side, and 1 minus square root of 1 minus t squared to the other side, and then we divide by 2 all out. Then sine of 16 all squared is equals to 1 minus square root of 1 minus t squared all over 2, which means now we can perform the square root, which is square root of sin 16 degrees all squared, and then the square root on this side, 1 minus square root of 1 minus t squared all over 2. And therefore, sin 16 will be equal to plus or minus. So it's plus or minus the square root of 1 minus root of 1 minus t squared all over 2. And there we have it. All 6 will be perfectly answered. So if you follow all these 4 rules, they are not the final thing, but mostly you'll get that you will be able to answer almost all the questions in regards to that. So thank you for watching, and please share it to the relevant people, and keep subscribing. Thank you.